Good morning. I'm Dr. Elizabeth Rani, Assistant Professor, Selection Grade, Department of AI&DS, KIT, Kalingar Karnanathy Institute of Technology, Coimbatore. Today, we are going to discuss the topic minimum spanning tree using Kruskal's algorithm in design and analysis of algorithm. Let's move into our topic. So first we should know what is meant by minimum spanning tree. So minimum spanning tree is the subgraph. That is what we called as the. So here, spanning tree is a subgraph. So minimum spanning tree means we have to produce the minimum cost. So that is what we are going to discuss here using Kruskal's algorithm. So Kruskal's algorithm will help you to calculate the minimum cost in spanning tree. So first we will study algorithm. What is what? So first we should know we are going to calculate the minimum cost in the spanning tree. So first algorithm step 1. So totally we are having the 3 steps. So first we have to arrange all the nodes, whatever the nodes it has been given, we have to arrange the nodes in the ascending order based on cost. So based on the cost, we are going to arrange the nodes in the ascending order. That is your first step. Next step, you are going to select minimum cost edge. So you are going to select minimum cost edge from the edge list. Okay, so we are going to find the edge list. In that you are going to select the minimum cost edge, and afterwards you are going to add into spanning tree. So here one thing is that it should not form the cycle. It should not form any cycle. That is your second. Suppose if you are having a question, suppose if cycle is formed means what I have to do? You just discard it. You just discard it. Third step, repeat step 2. Okay, what I have said in the step 2. So whether all the vertices has been covered or not, that you have to be check over here. So first again I am saying to you, first you have to arrange all the nodes in the ascending order based on the cost that was given in your problem. So through that you have to arrange the nodes in the ascending order. That is your first step. Second step, you have to select the minimum cost edge. So you are going to find the cost edge from the edge list, and afterwards you have to add into the spanning tree. The very important step is that it should not form any cycle. Okay, this is very important properties we have to follow in the Kruskal's algorithm. Third step, you have to repeat the step, okay, until all the vertices has been covered. I'll say what do you mean by vertices and what is meant by edges while we are solving the problem. So here once again I am saying 3 properties it should be satisfied. What is that means? First step, all vertices covered. Okay, which is I have said you in the algorithm. Third step, all vertices covered. Second, n vertices should be there, and remember n minus 1 edges should be there. Okay, you have to take n vertices. Edges how you will find means n minus 1. Third step, very important step, no form of cycle. This is very important property of the Kruskal's algorithm. So first step, all vertices covered. Second, n vertices should be there. Then afterwards, n minus 1 edges will be there. Third properties you have to satisfy as the no formation of any cycle. Okay, let's move into problems so that we can understand very easily what is what? Okay, I'm solving the problem. Problem 1, A, C, B, then afterwards D, then afterwards E. So 5, 3, 1, 2, then 2, then 10, then afterwards C to E, 5, D to E, 6, C to D, 12, D to D. Okay. So they have given you the problem. So you have to solve as the using Kruskal's algorithm. You have to find the minimum spanning tree. That is, you are going to produce the minimum cost. Okay. So first, if you look here, how many vertices are there? A, B, 2, C3, D4, E5, F6. So this is called as the vertices. So this is called as the vertices. Okay. Edges, I already told you the formula n. Okay, vertices is considered as the n. So edges is nothing but n minus 1. So you will get 6 minus 1. You will get as the 5. So we have found the vertices 6 and edges should be covered 5. Okay. Why we are saying like this means when you are solving the problem, at the time you can check it vertices 6 vertices are present, whether the edges should come only 5, like that you are able to check over there. Now we will follow the step 1. What I said in the step 1, arrange all the nodes ascending order based on the cost. Okay, so you are going to arrange the things. So this is considered edge, this is you considered as the cost. Okay, what is very minimum cost over here? 1. Where it is moving? C to F. What is the cost? 1. Okay, just you have to write it down. Next, what is the cost we are having? B2 we are having 2 times. B to F is also having as well as D to F is having. So you have to consider both the things. So B to F, first I will write 2. Then afterwards D to F also 2. Okay, then afterwards what is the minimum cost we are having? 3 is having, but 3 also 2 times it is presented, not a issue, we have to write both the things. So A to F is 3 as well as B to D is also 3. Okay, next we are going to find next we are having 5. So 5 also almost we are having two things. A to C is also there as well as the C to E is also there. Both we can write it. A to C 5 as well as C to E we are having a 5. Okay, then here I am writing. Then afterwards what is the things we are having? 6 we are having. So D to E we are having 6. Okay, then afterwards we are having 10. So 10 means A to B. You can look over here so you can understand. A to B 10, then C to D 12. So almost we have covered all the vertices as well as the edges, we have found it. Okay, so now we have to find the step 2. So we are going to find the minimum cost edge. You are going to select from the edge list and you are going to add it in the spanning tree. One thing you should remember, that it should not form a cycle. Okay, so first what is the minimum cost we are having? C to F. Okay, so I am drawing here C to F. Okay, as 1. Okay, next what is the minimum cost we are having? B to F. You remember you have to check the cycle, but starting stage there will be no cycle. Hereafter whatever the vertices you are drawing, edges you are drawing, means you have to check the cycle very immediately. B to F. Okay, B to F. Okay, no formation of cycle. So I am considering this one. So 2. Okay. Next D to F. Okay, D to F also not a problem for me because it is not forming the cycle. So I am taking that also. Next we are going to consider A to F. A to F where it is in the problem. Okay, no cycle. So I am considering. So what is the value it is having? 3. See, remember, in the all the vertices which we have been selected, there is no cycle formation. That is why we have considered. But when you are considering for remaining everything, you have to check whether the cycle is forming or not. Next, we are having B2D. Okay, so we are having the thing as the B2D. See, if I drawn here, what it is happening? It is forming the cycle. So I should not consider this one, which I have said the properties, very important property, no form of cycle. So I cannot consider this one. Okay. Next, so you just mark B to D. It is not possible to consider. Then afterwards we are having A to C. Yes, it is also forming the cycle. Just leave it. Then afterwards we are having C to E. No problem. C to E is not forming the cycle. So we are considering as 5. Okay. Next, then we are moving into D to E. D to E. Yes, of course it is forming the cycle. Please leave it. Then A to B, it is also forming the cycle. C to D, yes, it is also forming the cycle. Okay, C to E also it is forming the cycle. Just leave it. So we have just check what I told you. 3 properties, all vertices should be covered. Yes, A is covered, B is covered, C is covered, D is covered, F is covered, as well as E is also covered. No problem. First property we have satisfied. Then n vertices, n minus 1 edges. So what is our n vertices? 6. I already mentioned here 6. What is our edges? 5. So you just count it. 1, 2, 3, 4, 5, 6. All vertices I have been covered. How many edges I have mentioned? 5. 1, 2, 3, 4, 5. Yes, it is coming. So good. Then afterwards, no formation of cycle. Yes, of course, no formation of cycle has been formed for me. So the cost of spanning tree. So whatever the cost we have considered for our formation of a minimum spanning tree, all the costs you take it. So we are having 1 plus 3 plus 2 plus 2 plus 5. So total cost is 13. So this is known as the Kruskal's algorithm. Obviously, remember 3 properties, all vertices to be covered, and n vertices, n minus 1 vertices, then no forming of cycle. So this is the very important 3 properties you have to follow for the Kruskal's algorithm. Thank you so much. Keep commenting. Thank you.